Let's talk a little bit about parallel lines and the angles that they make. And there's some rules about them that we can use in geometry. First question, are these lines parallel? Okay, so have a look, see what you think, come up with an answer. I'm going to tell you that at the moment, they are not parallel. Now, even though they look like it, we can't assume that they're parallel. We have to put a special little symbol on them to say that they definitely are, and it's these little double arrows. So if you see two lines, even if they look parallel, if they don't have the little arrowheads to indicate that they are parallel, assume that they're not. Now they are, because I've got the arrowheads on them. There's another special line that I can draw, a straight line that cuts across a pair of parallel lines, and we give it a special name, and that name is a transversal. Really important, because when we do this transversal, when we draw this in, we create a whole heap of different angles, and we're going to go through and identify what some of those are for you right now. The first set of angles that we create are these Z angles. You'll see that they're kind of formed like in a big Z shape. Okay, so these angles just inside the inside parts of the top and the bottom of the Z, we call them alternate angles because they're kind of like on alternative sides of the Z. And the important thing about alternate angles is that they are equal. They are the same. So when we have a parallel line, a pair of parallel lines cut by a transversal, we know that these alternate angles are the same. So for example, if I knew that that angle was 40 degrees, then I know for certain that that angle there is also 40 degrees. We also get some F angles. Okay, so it's these, if you see, I've kind of got big F shape here. Okay, the angles that kind of form, I guess, on the arms of the F are the same. We call them F angles. The proper name, I beg your pardon, is corresponding angles, because they're on the corresponding parts of the F. And just like alternate angles, they are equal to each other. So if I knew that that angle was 55 degrees, I would know for certain that this angle here is also 55 degrees. We also get a different letter this time. You'll see the angles here are created kind of inside a C shape. So I'm going to refer to them as the C angles, but their proper name is co-interior. So in other words, they're both on the inside of the C, co-interior. Now, here's a question for you. Are they equal? Because the last two were, but if I have a look at them, it's pretty obvious they're not. This is an obtuse angle because it's bigger than 90 degrees, just looking at it. And this is an acute angle because it's less than 90 degrees. So they cannot be the same. So that's not going to work. What we do know, however, is that they always add up to be 180 degrees. Special name for angles that add to 180 degrees is we call them supplementary angles. So if I knew that that was 35 degrees and I needed to know this unknown angle here, I could say, well, x plus 35 equals 180. In other words, something added to this 35 degrees has to add up to give me 180. And in this case, I would know that that is 145 degrees. We also get two other little sets of angles, and we don't have fancy letters for these ones. We just know that they exist. So I've got here two angles that are vertically opposite. So wherever I've got two straight lines that cross, like these ones here, I automatically get opposite angles. And nothing fancy, but we just call them vertically opposite. And the great thing about vertically opposite angles is that they are equal. So if that was a 43 degree angle there, I know for certain that the vertically opposite angle is also 43 degrees. All right, the last one we want to look at is the angles on a straight line. So if I've got you see I've got a straight line here as part of my parallel lines. Well, that forms two angles with this transversal, one here and the other one. And if I add them both together, they form my straight line. Angles on a straight line always add up to 180 degrees. Okay. Oops, let's go back here. So if I knew that this, say, was, I don't know, say 100 degrees, this one would have to be 80 because they have to add up to give me 180. So here's an example of the kind of questions you might get. And I guess if you think of these geometric questions, kind of like geometric crime scenes, I suppose, in that you turn up at the crime scene, there's clues around, and you need to solve the crime, and you need to use the tools at your disposal, which are those rules we just learnt. Here we go. Example, find the values of angles X and Y. Okay, first thing we look at here is we see this X is vertically opposite this angle. Now I know from my rules that vertically opposite angles are equal. So if I wrote X equals 60 degrees, technically that answer is correct, but you'll see down here I've said answers must include your reasons. Okay, so all I've had to do to give a reason is I've just put in the brackets here that they're vertically opposite, and that's enough. Okay, that's like saying I've used this tool to solve it. Here's what I used. I used vertically opposite angles. Okay, so now I know that this is 60 degrees in here because it's vertically opposite, and that's what I've written. Can I find out a value for Y? Well, if I have a look at that, I've kind of got an F angle. Even though it's a back to front F, the rules still apply. And I know, if I remember from my notes, that my F angles are called corresponding angles, and they are the same. So Y must be 60 degrees because it is the same, or it is the corresponding angle to X. And I have to write my reason. So I've just simply written there that they are corresponding angles. Okay, that's it. That's parallel lines and their angles, and how we can use those laws and those rules to solve some of these types of questions. Well done.